Hello, this is Mrs. Ward, and I'm going to go over numbers 1 through 6 of the review worksheet for 9.2 ellipses. The second half of this review worksheet will be in a separate video. All right, the first one, number 1, it asks you to identify the center, vertices, foci, and eccentricity of the ellipse. It's already in standard form, which makes my life so much easier. The center is just going to be whatever I'm subtracting from the x, whatever I'm subtracting from the y. So my center is going to be the ordered pair 3, -1. When I look at this, remember A is always your largest number. So in this case, my A is going to be the square root of 25, or 5, because 25 is the larger number. B is going to be the square root of 16, so that will be 4. So the 5 is underneath the y. So to find the vertices, I'm going to add and subtract 5 to that y coordinate. So I'm going to end up with 3. When I add 5, that will be 4. And when I subtract 5, that will be -6. So my vertices are 3, 4, and 3, -6. And then those are my major vertices. If I were graphing this, I would also want to find my minor vertices, which would be adding 4 to that 3. So I would have 7, -1, subtract 4, and -1, -1. Those are my minor. I think they're helpful to have. You have to write them, not all the time. The foci, in order to identify the foci, I have to find my c. So remember, c squared is equal to a squared, which is 25, minus b squared, which is 16. When I subtract those two, I get 9, take the square root, and c is equal to 3. So to find my foci, I'm going to add and subtract that 3 to the major, which in this case is the y. So I'm going to have 3, the x coordinate will stay the same in this case, and then -1 plus 3 will be 2, and then -1 minus 3 will be -4, and those are my foci. And the last thing it asks me for is the eccentricity. Eccentricity is just simply c over a. So in this case, that's going to be 3 over 5. And those are the points that they wanted me to find. Okay, looking at number 2, I'm doing the same thing. It's already in standard form. So my center is going to be whatever I subtract from the x, which will be -1. My y coordinate will be whatever I'm subtracting from the y, which in this case will be 5. My a, the largest of those two numbers, and my denominator is 12, so my a is going to be the square root of 12, which is 2 times the square root of 3. B would be the square root of 8, which is 2 times the square root of 2. So when I find my vertices, and I'm going to do the same thing, I'm going to find my minor and my major. So my major ones are the ones that the book usually talks about. That's going to be taking the larger one, which is 12. See how 12 is with the x? So I'm going to add and subtract that 2 times the square root of 3 to the x coordinate. So I'm just going to write -1 plus or minus 2 times the square root of 3. That's going to be my x coordinate, and then my y coordinate will be 5. That's my major. To do my minor, my x coordinate stays the same, so that -1 stays the same, and it's going to be 5 plus or minus the b, which is 2 square root of 2. So since those are complex numbers, I cannot simplify them, so I'm just going to leave them like that. Now I need to find my foci, which means I need to find my c. So remember, c squared is equal to a squared, which was 12, minus b squared, which was 8. And when I do that, I get c squared is equal to 4, which means c is equal to 2. So my foci is going to be my x-squared, which is -1 plus or minus that 2. So -1 plus 2 would be 1, 5. And then -1 minus 2 would be -3, 5. So those are my foci. And my eccentricity, I'm just going to take my C, which is 2, over my A, which is 2 square roots of 3, which would be 1 over the square root of 3. And if I rationalize, would be the square root of 3 over 3. And that would be my eccentricity. Okay, moving on to number 4. I'm sorry, number 3. Don't know how to count. Write the standard form of the equation of the ellipse. So all I'm going to do is I have to put my x's together, my y's together, complete the square. So I'm going to say 9x squared plus 36x plus 4y squared minus 24y, and then putting that 36 over to the other side to get it out of my way for completing the square. Okay, this one I'm going to complete the square. I'm going to first factor out that 9. So I'm going to do 9 times the quantity of x squared plus 4x plus, and I like to leave a space. Then for the y's, I'm going to factor out a 4 and make this y squared minus 6y, and then again I like to leave a space. And then that's equal to the negative 36. So when I complete the square, I am going to have, there's the 9 that I factored out, x plus 4 divided by 2 is 2. 2 squared is 4. But I'm really adding 9 times 4, so I'm really adding 36 to this side, which means I'll add 36 to this side. Doing the y's, I'm going to have plus 4. Half of 6 is 3, so I'm going to write minus 3. 3 squared is 9, but I'm adding 4 times 9, which is 36, so I'm going to add 36 here. So when I add negative 36 plus 36 plus 36, that's all equal to 36. Remember, these have to be set equal to 0 or equal to 1, so I'm going to divide by whatever number's over there. So I'm going to divide everything by 36. When I do that, these will simplify and I'll end up with x plus 2 squared over 4 plus, these will simplify and I'll be left with y minus 3 squared over 9 is equal to 1. And that's all they wanted me to do was write the standard form, so I am done at that point. Moving on to number 4. Doing the same thing, I'm going to put my x's together, my y's together, and then everything else over to the other side. So I'm going to have 36x squared plus 48x plus 9y squared minus 36y, and then putting that 43 onto the other side will be a negative 43. When I go to factor out, I have to factor out whatever the lead coefficient is of the x squared. So I have to factor out this 36, which is fine for the x squared, but it does not, 36 doesn't go into 48 evenly, and that's okay. I still have to factor that 36 out. To find out what number I put here, I take 48 and divide it by 36, and when I do that, I get 4/3 x, and then I like to leave a plus 1 or plus blank space. Then I'm going to factor out a 9 here, so this will be 9 y squared minus 4y plus some number, and then that's still equal to a negative 43. I don't know that we'll be able to put that in there. I'll squeeze that in there. Okay, now I'm going to complete the square. I'm bringing down this 36. Here's x, here's a plus. Half of 4/3 would be 2/3. 2/3 squared, well, 2 squared is 4, 4 squared is 9, so that's 4/9. But what I really add to this side is 36 times 4/9, which I believe will be 16, which means I'm going to add 16 over here. Then I'm going to have plus 9. Y, half of 4 is 2. 2 squared is 4. But I'm really adding 9 times 4, which is 36. So 36. So on this side, I had negative 43 plus 16 plus 36. So when I add those all up, I believe this totals to 9. So that's all equal to 9. In order to put it in standard form, I have to set this equation equal to 1, which means I am going to divide everything by 9. And when I do that, this will simply be y minus 2 squared, and it's over 1. And I know I don't have to write a 1, but I like to write a 1, so I'm writing a 1. Here, when I divide, I will end up with 4 in the numerator and 1 in the denominator. The problem is I need this up here to be a 1. So the easiest thing to do is to multiply this by 1/4, which would mean I would have to multiply the denominator by 1/4. So this will end up being x plus 2/3 squared over 1/4. And again, we've talked about that. It's okay to have a fraction within a fraction for the equations of an ellipse. Okay, number 5, they want you to write the standard form of the equation of the ellipse and then find the center, vertices, foci, eccentricity. So this one, I don't have any binomials. I'm not adding or subtracting anything from the x to the y. So in order to solve this, again, it still has to be set equal to 1. So I'm going to divide everything by 36. And when I do that, I end up with x squared over 36 plus y squared over 9 is equal to 1. My center is at the origin because I'm not subtracting anything from the x to the y. My vertices, so let's do the major first. So a will be the square root of 36, so a is 6. B will be the square root of 9, so that would be 3. My major vertices, I'm going to add that 6 to what variable goes with, which is the x. So it'll be 6, 0, and negative 6, 0. If I were graphing this, I would want to know my minor vertices. And so those would be 0, 3, and 0, negative 3, because you're going to add and subtract that 3 to the y. To find the foci, I need to find my c, so I'm going to say c squared is equal to a squared, which is 36, minus b squared, which is 9. So I'm going to say c squared is equal to 27. So c is equal to, oh, 9 goes in there, so 3 times the square root of 3. And so now to find my foci, I'm going to add that 3 square root to 3. I'm going to add and subtract it to the x coordinate. So my foci is going to be plus or minus 3 square root to 3. And then my y coordinate stays 0. Finally, my eccentricity, I'm taking my c, which is 3 square root to 3. And I'm dividing that by my a, which is 6. The 3 and the 6 will simplify, and I end up with the square root of 3 over 2, and that's my eccentricity. Okay, moving on to the number 6, we are going to do the same thing, except for it is not in a nice standard form. I'm going to have to complete the square to put it in the standard form, so I'm going to complete the square for the x's and the y's, but before I can do all that, I have to put my x's together, so I'm going to say 12x squared minus 12x plus 20y squared plus 40y, and then putting that 37 over to the other side, it's equal to a positive 37. For the x's, I'm going to factor out a 12, so I'm going to make it 12 times the quantity of x squared minus 1, x, and then I like to leave a space. For the y's, I'm going to factor out a 20, so this will be plus 20, and then this is y squared plus 2y, like to leave a space, and then this is still equal to 37. completing the square for the x's, I take half of the middle term. So half of this one is 1/2. So I'm going to have x minus 1/2. 1/2 squared will end up being 1/4. But 12 times 1/4 will be 3. So I'm adding 3 to the other side. Now doing the y's, I'm going to have plus 20 y, and then half of 2 will be 1. 1 squared will be 1. 20 times 1 is 20, so I'm going to add 20 here. So when I add 37, 3, and 20, I get 60. To finish this off, I have to set this equal to 1, so I am going to divide everything by 60. When I divide everything by 60, I end up with x minus 1/2. And this will be over 5 plus y plus 1 squared over 3, and this is equal to 1. So my center is whatever I'm subtracting from my x and whatever I'm subtracting from my y. So my center will be 1/2 -1. My major vertices will be, the 5 is the largest, so a is going to equal the square root of 5, which I cannot simplify, and b is going to equal the square root of 3, which I cannot simplify. Square root of 5 is larger, so I'm going to add that square root of 5 to the x-coordinate. So my major vertices are going to be 1/2 plus or minus the square root of 5, and my y-coordinate stays the same. My minor vertices, again, just if I were graphing, I would have to list those. My x-coordinate would stay the same, and I would take -1 and add or subtract the b, which in this case is the square root of 3. To find the eccentricity, I need to find c, so I'm going to say c squared is equal to a squared minus b squared. So c squared is equal to 2, which means c is equal to the square root of 2. To find my foci, I'm going to add that to the x-coordinate. So my foci is going to be 1/2 plus or minus the square root of 2, and then my y-coordinate stays the same. The eccentricity, so I'm going to just say E is equal to C, which is the square root of 2, over A, which is the square root of 5. I like to rationalize, so I am going to rationalize. I'm going to multiply by the square root of 5 over the square root of 5. So I end up with the square root of 10 over 5. Cannot simplify that 10 and the 5, so that would be my final eccentricity, is the square root of 10 over 5. Okay, I hope this helps with numbers 1 through 6. If you want the solutions or 7 through 10 explained, just go to the next video. Have a great day.